Last time on Tom's 3D Live, we created a Sharpie test assembly with an anvil, a Sharpie specimen, and a Sharpie Pac-Man hammer kind of thing. But I completely failed at creating a swing arm for this hammerhead because, like, you know, relations and whatever. We changed this design around and ran into some issues with clearance. Where the traditional hammerhead, which I don't have with me right now, I think I took it back down to the workshop, just didn't fit through whichever holder we might be able to create for this Sharpie test. And my phone is notifying me, oh yeah, Tom's 3D is live. Well, that's cool. That's cool. Anyways, today I'll try to create a hammer arm for this guy and maybe create another Halloween test, because I do still need to create one for filament softness essentially, but we'll get to that when the time is right. Is this muted? Yes, it is. Okay, so last time we had this Sharpie hammer arm that yeah, it didn't work. It didn't work out. Hey everyone, people are starting to come in. So I guess YouTube notifications do work. That's cool. So yeah, this hammer arm just didn't work. Let's just get rid of it. I think we can undo that if we need to, maybe, but yeah, that just did not work out. So let's create that from scratch. Mega making, yeah. Good night, man. Good night, man. No need to keep yourself awake. This isn't a live stream you need to be watching. Yes. Oh yeah, view counts just dropped. Whatever. But so the idea is I'm just going to create the bearing hub that's going to sit up here. I'm going to create that as a separate part, because that's something that I think I tried to recreate like 3 times in the last stream. I'm just going to create that as a separate part right now, and then insert it into the assembly and design the rest of the arm around that, because we have the 2 holes right there. We have our mounting point in the center, and that should be pretty good. So this is going to be the hammer, come on, hammer arm. And I guess right side is where we're going to start. So 22, 33, well, 20, 30, let's make that 40, just to give it lots and lots of meat around the center bearing. This, well, I guess the dimensions down here where the hammer is going to sit is going to be separate from this anyway, so let's make this as wide as reasonably possible to make it as stiff as possible, because we don't want that hammer to wobble around. It's going to wobble around anyways. So let's just start out with, well, let's not do it like that. Let's do it as a 1 feature revolve. New sketch right here, perpendicular. Let's do it as a proper sketch. Q construction. So first bearing seat right there, second bearing seat right there, and then the meat on the outside. So this was going to be 40, and it scales the entire thing. Is Onshape free? Onshape is free. There is no feature limitations or whatever. The only, well, there is a feature limitation. There is the feature limitation that it cannot save private documents. So anything you design is going to be public. So it is going to be visible to other Onshape users. I'm fine with that. I'd rather have that than some other weird limitation that Fusion 360 has, but that's, you know, up to that's up for everyone to decide on their own. I personally just prefer this type of approach. Coincident, there we go. So those 2 are lined up. Perfect. And that is basically the entire design. Would I recommend it over Tinkercad? Yeah, pretty much. The question is, what is your level of like CAD knowledge? Tinkercad is extremely basic compared to what Onshape does. Onshape is you know, something you could compare to SolidWorks, to you know, Inventor, whichever one of the big CAD packages you want to the CAD packages you want to compare it to. It's not a, you know, a playful, well, I guess it could be. It's not something that, why did I not just mirror this? It's not something that's just this playful approach. It's a real CAD tool. I don't think it's really that hard to get into. But again, it's free. Just try it out. It's not that you know, it's if you don't like it, cool, try something else. It's free. Is it comparable to SketchUp? I've never used SketchUp, and whenever I hear SketchUp, I hear people screaming, "Oh, don't touch it!" So yeah, is it comparable to SketchUp? It's probably more involved. Well, it's more powerful than SketchUp. I don't know if it's actually more involved than SketchUp. Okay, I actually do have to confirm that instead of just hammering escape. I see the part I hammer escape. Not cool. So should I make this flush for now? I don't think so. So we have this mate connector. Can I define a distance? I think I might be able to. So that would be a revolute mate, and then I think I should be able to define a distance. Okay, we have mate connectors. We're gonna add one to this position right here, and then we're gonna mate up to a, well, actually no, slider mate, because I do want to define the distance somewhere. So if you say offsets, is that going to offset the center point? Let's see, 5. Yeah, that just slides it around. Limits, minimum, if you say minimum 2, max, well, -2, -2, it's going to be stuck in that very position. Perfect. FreeCAD versus Onshape versus Fusion 360. I guess Onshape and Fusion are direct competitors. FreeCAD I've tried using. I never got the hang of it. It just never clicked. It always felt extremely over complicated. You know, it just didn't feel good. And Onshape does feel good for me. So yeah, versus Fusion 360, I think whichever one you like better, whichever license model you like better is going to be the one for you. I think you can do pretty much everything you can do with Fusion 360 in Onshape and vice versa. Oh, that's the wrong mate. Specifically thoughts on FreeCAD. Yeah, I don't like it. I know it's free, it's open source, that has its own merits, but I just don't like it. It's just, it makes everything so complex, so involved, and I like getting stuff done fast. As well, I don't want to spend more time on stuff than I have to. Inland filament, haven't tried it out yet. Right, so let's just what? Oh, this is vertical. Okay. Let's just do basically the same thing again that we did last time. What is the best printer? Sub $200. I'm not gonna have one that I can like recommend because I've not reviewed that many sub $200 printers. I've not reviewed them in depth yet. And you're probably not gonna have much of a choice. You're gonna get one of the 8 kits, and that's it. That's it. The dolly, yes, the Mark II DIY printer is a good approach. I think it's a really good printer if you build a few things differently than I did. More videos coming soon. But depending on what sort of machine park you have access to, because you do need a 3D printer to make the dolly 3D printer. That's one thing a lot of people get weirded out about, because it's yes, that's the exact idea. You need another 3D printer to make this 3D printer. But yeah, if you have a 3D or access to a 3D printer, then it's certainly a good choice. Did you create a circle? Yeah. The Mark 42 bed will make it over. We'll push it over $200, depending on how much you're paying for it. It's the same thing as always, depending on how much you're paying for 3D printed parts. If you can print them yourself or print them in a fab lab for material costs, then of course you're going to have a much easier time making the printer for cheap. So folding 3D printer build from open builds. The one thing I guess I'd be worried about is whether the registration is going to be okay when you take it out of your folded up state, whether you can actually hold on, up to part. Can I just say up to part right there? When you take it out of the take it out of your folded up state, is it going to be square? Is it going to be tight when it's up to vertex? Is it going to be tight when you reassemble it? So that would be my main concern. But other than that, I think it's a great idea. Maybe make it battery powered. That would be awesome. Have you used Onshape to run my CNC router? No, I have not. And what I have as a CNC thingy, I wouldn't. CNC routers may be a bit too generous. Okay, there's the arm. That's all going to be infill. That's going to be cubic subdivision infill, I guess. It's really long at this point. I think I'm just going to split it down the middle in a second using a surface or a boolean, whichever one. Okay, screws from the back through the plastic part into the metal. Probably nicer. Auto leveling. Yeah, the thing is though, if you have weird geometry in your 3D printer and you try to use auto leveling, you might end up with some weird geometry shifts in your print. So if you have a z-axis that doesn't end up square, auto leveling won't be able to do anything against that. What am I doing? Actually, no. Actually, let's get rid of these. Let's just cancel this sketch, because we do have these 2 points, and I can use what the diameter did we make these? These are 5.5, so that is an M6. Should you print a dolly i3 or a hang printer? Probably an i3, probably the dolly i3. The hang printer is a very specialized piece of kit. I am fascinated by it, but it has its applications, but it's not as versatile of a 3D printer as a regular i3 style machine. Editing context, we have these 2 points on the back. Let's actually get this guy visible and use the whole assistance clearance for M6. Standard fit. Actually, I think we can make it, we can make it a close fit. And it's going to be here and there. And counterbore, perfect. That's going to fit a DIN 912 screw perfectly. Sweet. It's unprintable at this point with the bearing seat and all, but yeah. Do it versus Smoothie. Any thoughts? I think Smoothie is more of a DIY solution, more of an involved piece of kit, while Do It can be a very nice, more of a plug and play, ready-made solution. Maybe they're very similar. They're very similar platforms. I think the Do It board is a bit more modern than the Smoothie board. The Smoothie board has been out for a good while. You do get TMC drivers on the Do It, at least on the Do It Wi-Fi. But yeah, very similar platforms, whichever one you like better, I guess. So we have a bit of clearance here, which should be okay. Why is Philween called Philoween? Because it was started around Halloween and the name just stuck, I guess. It's gonna make sense in a few months again when it's end of October. It's you know, it's gonna make a lot more sense than it does now, but I like the name. Yeah, have I heard something about the no ooze nozzle? No, I have not. Right, what am I trying to do? I'm trying to split this thing in half. Okay. Let's see, front. So part, can we get some, so this is a weight, center of mass, surface area. Do we get some length info somewhere? I guess if we just sketch and draw a quick box around this guy. There we go, so that's 276. So that would fit on the Sigma in the single piece. Should I split it, or should I split it or should I leave it in place? I guess diagonally it would also fit on Mark II. I'm just gonna leave it like this, I think. Okay, Amazonations, if you need to manufacture 50 fidget spinners, should you 3D print them or mold them? I think you should just re-evaluate what you're doing with your life, because one fidget spinner is already more than enough. So it's already too much. So if you're gonna do 50, I don't know what the hell you're up to, but something's wrong there. Okay, there's one more part that I need to make. There's just gonna be a washer between the wood backing and the bearings here. I need to make a quick and simple, well, support, 8mm support on the back here. So that's just going to be another part. And let's make it a revolve and add a few through holes to that. Should work. So top, why am I sketching top? Let's do front. Okay, if it's a science project, also maybe make something other than a spinner. But whatever. Should you 3D print or mold them? 50 is like a weird number, because the molding is probably going to make the entire process a lot faster, but setting up the molding and learning how to do that right might just take you a lot longer than hammering them out on a 3D printer in the first place. I 3D print them, depending on which 3D printer you have, because those spinners, you know, they print fast. So something like this, I suppose. So we're just going to have an M8 or an 8mm shaft in the center here. Oh, I guess it's going to be M8. maybe have this with a step down. 5. Well, I suppose most 3D printers could hammer them out pretty quickly. Am I going to reinforce this with something? Yes, I am. There is going to be, let's make this 100. There is going to be some extra scaffolding on the, let me just show you. So this obviously is just 10mm MDF sketched out. There is going to be some scaffolding on the back. Just angle brackets are not going to do much. The MDF is just going to flop around, but I'm just going to have a, a thicker structure that is perpendicular to this part down here and going all the way around. And that's just going to, well, it is going to make this thing enormously stiff and hopefully somewhat still light. So hammer arm, we got this. We need the Part Studio one. Okay, rename. So 8mm reinforcement. You have problems with the original E3DV6. 85mm a second. It's built up a back pressure and the extruder is clicking and grinding. Check your extruder, maybe, but depends on which setting you're printing or which settings you're printing with. So if you're printing, oh, GeForce Game Ready drive is available. Cool. If you're printing very cold, for example, or use a very high fan speed that is blowing directly over the nozzle, then that's gonna, create a lot more back pressure than no fan and higher temperatures. So check the external parameters first. Circular pattern. Let's do 6. Did that do it? Yeah, okay, 6 points. We did not define a center point, so we can always do that later. Perfect. And now for a few holes, and this is, wow. So let's do a counter sink. Clearance for, well, M5 or something. This is going to be wood screws. Sketch point. What surface for a heated bed? It depends on what material you're printing. Anything from PEI over glue stick over any of these spray-on adhesives is going to work just fine. If you have a heated bed, you have the most well, you have the most important factor already figured out. Cool, that's just going to bolt to the back side of this thing and is hopefully going to reinforce it. So yeah, PLA, anything goes. Let's just add this guy and we should be good to move on. There's obviously going to be another hole in here to allow the axis or the axle to go through, but so that's going to be another slider mate. Other way around, and we're going to create a limit, and that's going to be 10, 10, negative 10, and negative 10. Perfect. Now that thing is sitting on the back, and we have a a reinforcement for whichever 8mm axle is going to go through this guy and into the bearings over here. Cool. So this guy is pretty much figured out. Ah, nice. Change the PTF E-tube. What? Which E3D hotend are you using if you... Well, I guess the PTF E-tube on top. Because original V6s don't have a PTF E-tube in the heated area, and the top one barely makes a difference. Yeah, glass and glue stick. What's also going to work is just plain glass, especially if you want something that is easily removable. If you have, well, borosilicate glass works a bit better for this, but any glass that is really nice and smooth. So you guys, anything that is smooth and you wipe down with alcohol. Fixed in an offset. Okay, cool. Thank you for that. Wipe down glass with alcohol, and that's going to stick really well to PLA and too well to PETG. Yeah, I guess I can just do a fixed one, fastened, and yeah, offset it. All right. Learned something again. Will there be a follow-up video on the dolly? Yes, there is lots more planned for dolly, including fixing Z-wobble, etc. Just piece by piece. So many things to do, including like Halloween right now. But it's still planned. It's still planned. What is this? This is hardness test. So yeah. Chuck, there we go. Let's just quickly recap this, guys. So the anvil is done, the specimen is done. This is going to get printed, and yeah, if the hammer has trouble demolishing this specimen, essentially, I'm just going to print this with less walls, so that's going to be fine. The arm is done. That's going to get printed diagonally on a Mark II or on the Sigma. We'll see. And the reinforcement on the back is done too, and there are going to be perpendicular wooden reinforcements on the side here, so got that figured out. So yeah, this is printable. I just need to get some wood and get the hammer made. If that doesn't work out, I can always just modify this guy. So now a test for material flexibility. Have you seen these? Probably not. These are the prints from the live stream, cable management live stream on the other channel, on the main channel. But yeah, some materials are more flexible than others, as in softer. So what I used to do, I don't have one here, but I can show you. I have the bend test. I used to just put this in the chuck like that. Put or pull down with about a 1 kilogram load and see how far this side bends down. That wasn't great. That wasn't great at all. The problem was, first of all, it was very hard to accurately pull down with a 1 kilogram force. Yes, I could have just used a weight, and I'm going to do that probably. It was very hard to do that accurately. And also the parts, it was very hard to read off how far it went down. So I actually looked at the videos frame by frame and looked at which millimeter it started and which millimeter it ended up. And depending on which material it was only like 4 or 5 millimeters that it bent down. And that's not enough to make an accurate observation. And yeah, that's the other thing. And yeah, some materials that were too soft just kinked completely and just flopped down. So I wasn't able to get any sort of reading for those. But well, I guess it's also not going to be it's going to be a non-linear test in a certain extent. But what I tried to do is create basically a spring shape, a shock type shape with a few stacked ovals that compress or get pulled essentially. And that should be a lot softer, a lot more flexible than what I used to have, and also be much easier to read off. So let's try and do that. Am I interested in doing measurements on a tensile machine? Maybe for one or two materials as a reference, but not for every single one. It's just too much effort. It's impossible to do for every material, especially, you know, I keep bringing this up. If you use a proper tensile testing machine, sample size of 1 just makes absolutely no sense. So we need to make sure that your results are reproducible. We need to make sure that make sure you do thin feature. No, you need to make sure that they're reproducible, that they are properly done, and that is it's just impossible for all the fill lead materials. Let's face it. I would like to do it, sure, but all within my you know, what's reasonable for testing filaments, because I mean, let's face it, one batch of filament to another is going to be different as well. It's not going to be the manufacturer is probably not going to be able to manufacture parts that accurately in the first place. Why can I not do a negative offset here? 1, yeah. -1. This is not what I wanted. Just do another one right here. Click, click, click. That's going to be 36, 26, 26. And that's going to be 6. What did you lose? This guy is now somewhat done. Yep. Hardness test. That's going to be our individual spring elements essentially, and I'm going to stack these up with an 8mm pattern. Is this even a constant wall thickness? It doesn't look like it. Well, I can always play with the thickness here and see how much I need to make to make it strong enough and you know, meaningful for the sort of weight I'm putting on it. Delay makes it really hard. Delay, let's see how much delay I'm getting in my preview player. I'm getting 11.5 seconds delay. That's as good as Twitch. So yeah, 10 seconds delay. Pretty solid today, pretty solid. Make notches to put in digital calibers to measure how much the inside distance from top to bottom decreases with a given weight. I'm just gonna have a direction. Oh gosh, we don't have a direction to select, and we can't select any of the. Can we select the plane? Oh, we can select the plane. Okay, learned something again. I'm just gonna have a. Oh yeah, which was all. I'm just gonna have probably even a pointer on this part that just points over to a paper scale. So, is there a wall option? Maybe somewhere. That might be too long and too springy. Is that even gonna be springy? I think it is somewhat. Let's make this. Can we do? Let's see. Can we do a? Extrude only does solid areas. It doesn't do wall features. But we can do a wall, a surface, and then add thickness to that. but for now this is gonna be this will need to be okay. Let's bump that down to 24 and 20. That looks a bit better. If you use a Ryzen processor, the stream would be better. Nah, we good. We good. Okay, just a few. Well, I guess all I'm gonna need is a hook up top and a hook on the bottom. So let's add this. Oh gosh, okay, point right there, that's our origin. And this is gonna be on this inner edge with this. Here we go. And then we can align this to this one right there. Yeah. And for this one, the offset should work. Yeah, perfect. Dimension 20. Well, let's dimension the inner one because we can. So there's going to be a. Well, I guess 10 is okay. It's just going to get a S hook or something through it that I can hook a weight onto. So this is going to be fine. This part right here shouldn't stretch too much. But yeah, looking good. What are we making? More Halloween tests. Can I do some? No, I can't. Okay. More Halloween tests that let me determine the. I should have just mirrored this entire thing. Let me determine the hardness of a given material. Get out of here. So can I just mirror this guy, or don't think I can, because this guy, well, with 10 elements we can have a mirror line, so I guess I can just go into the sketch. I wish Onshape had like a view perpendicular option for a sketch. What's even happening? It's probably hidden somewhere, but it's one of the features from SolidWorks that I like really liked. This is I. Why does it have to be I? And let's mirror these guys. Is it M? No hotkey there, unfortunately. So it's only extruding this one down here because we only have this face or this area selected. Let's select this one up here too. And there is our test part essentially. So it's going to be fixed at the top. It's going to get a severage test. What? The right button menu when you click the sketch in the nope. Oh, view normal too. Okay. Okay. I thought I had looked for this before, but well, okay. Every time I use Onshape, I learn something new. Something that yeah, 3-point bending test. So many. Yeah, I was thinking about that, but again, I feel there is a need to explain this as many times as possible. Halloween is intentionally not set up to look scientific because it is not. It cannot be. If I would do scientific tests to the extent where I'd be happy with calling it a scientific test, it would take me a few weeks for each material. It's just not feasible. Instead, I'm designing these tests, these simplified, dumbed down tests that do not look like, well, I guess the Sharpie one is the one that, but the Sharpie one is reasonable. It tests exactly what I want to tell, and it's simple. It's literally just a hammer swinging against the part. But all these other parts are dumbed down versions of some sort of bending test or some sort of standardized test, but intentionally not exactly what the proper test is. Again, because I don't want it to look like it is that test. I do not have the means to create proper results that would deserve the label scientific, so I don't want to create any opportunity for people to mistake these for tests that are set up to be scientific. Hence this guy. Severage test. What was that? Severage test. Sewer testing? Engineering marvel under Northern Surge. Hey! Okay. That should be somewhat flexible. We could run a simulation on that and just pull it. Let's see, this thing. It might be a bit too large to be easily printable, but I can always scale this down. So, yeah, this should be good. Yeah, Stephen, that is pretty much Stephen Allen saying we need a ballpark comparison because of printing variances. That is correct, yeah. 10 degrees hotter or colder definitely affects it. Using more or less material also affects it. It's like pretty much anything you could change about your printing parameters is going to affect material strength and material print quality. I am planning on doing a bit more tuning with Filween 2.0. Can I rename this? Rename document. Manufacturer recommends. So yeah, printer is going to be the Mark II as usual. I have two of those. Those are incredible workhorses. They just keep on working well. So yeah, that's that. We have the Sharpie beater. Sharpie whacker, I guess. Yeah, reinforcements there, and the hardness test. I think for these guys, I think I'm actually going to keep these in place. These are super simple to print. These are two parts for these, vertical, horizontal. I'm not sure if I'm going to keep these. Because if you look at the Filween table right here, so what I've been seeing, I think, is basically the pull test and the bend test. Well, I guess they're simple to print. The pull test and the bend test were usually giving very similar results. So if the material would perform well in one of them, it would also perform well in the other. However, the pull test had some, like, what is this? Tallman 910, Tallman Bridge. What's this stuff? Polycarbonate. Some of the materials that were just tough. These tests just wouldn't fail it. They just wouldn't tear. So actually you can use this link right here. This is shared, and you can see that there are a few people in this document right now too. Yeah, the pull test sometimes wouldn't get good results. I'm just gonna think about that and see how much sense it makes, essentially. But on the other hand, this guy, Here we go. This guy sometimes also didn't make sense. Oh, bottom, I need to add that label. This guy sometimes also didn't make sense for the softer materials, like this would just flop down. And I guess that's what this test is for. So for the materials that that this test didn't work out, I had, here you go, this one. Well, I'm just gonna well, see where we get. The question was, what camera do I use? There we go. This right now is a Logitech C170 webcam. I got that one for free somewhere. But for my regular videos, it is a Panasonic G7. Liking that camera a lot. Cool. I think we are done here. This guy just, I'm just gonna print it a few times. I'm just gonna see how well it does, how soft it ends up. One more thing I should add, which is a little pointer on the last flexible lip right here. Actually, did we extrude this symmetrical? Yes, we did. So sketch on the bottom side right there. Okay, but now the right click doesn't work anymore. We can do a view normal to here, but we can't do it here. Okay. Back, so that would be over here. Can we actually get a triangle? Yes, I think we can. Inscribed polygon. Right there, and then do 3. Vertical. Coincide right there. And dimension this to 4. Perfect. There's our little pointer. Do the right click in the 3D view. Cool. But I don't understand why that is here now instead of there. Thanks for that. Nope. Why did we do this on the front plane? I did want to do this on the back surface of the sketch. And now the triangle got flipped. Cool. I don't think I can unflip this. Can I? Oh yeah, I can. Sweet. Curved plates for costumes. How about some kind of deformation resistance test? I guess that would be exactly what I'm trying to do with the hardness test, because you know this thing is, I think, way too large. The softer a part is going to be, the more deformation I'm going to get here. So I guess, yeah, this is going to be exactly what you're looking for. All right. Yeah, that's pretty much going to be it for today. How long did I stream? Half an hour? Pfft, that was quick. But yeah, I'm going to try these out tomorrow. And tomorrow is going to be the Hack-A-Day prize in Munich, and Saturday and Sunday is going to be the Make Munich. If you guys look through the exhibitors list or project list on Make Munich, and you see one that you'd like me to cover, tweet at me. Let me know. I'm going to be there at least Saturday, maybe Sunday too. Let's see how long that's going to, or how long it's going to take me to see everything. But yeah, I'm going to be there. If you see something that's interesting to you, let me know and I'll cover it. So yeah, stay tuned for Filming 2.0. These things are looking nice. It's just completely over the top. But yeah, heat stability test. Again, there are a lot of tests that would be better what I'm doing here, but it's about efficiency. How fast can I do them? Because I want to test as many filaments as possible. I do have like 50 that I need to test. So, and it's about, you know, being simple and not being like acting like it's scientific. So yeah, thanks for stopping by, and have a nice evening. Goodbye.